Okay, so can I have your attention, please? Okay, so we're going to start on the second part of trigonometry, okay? And hopefully we'll kind of talk you through it, we'll take a break, and then you can have a go at some examples after the break, okay? So far, trigonometry that we've used has been applied in what type of triangles? Yeah, right-angle triangles. Now, on that side, when we're starting to talk through trig graphs, we talked about how we could use trigonometry with angles which were bigger than 90 degrees, yeah? But I want to go back to this idea of triangles, okay? And I want to show you that there are some instances where you can use trigonometry in non-right-angle triangles, okay? And this is how. So I've drawn a non-right-angle triangle on the screen, or on the board, right? Now, do you notice that I have three angles? So I'm just going to label them. I'm going to go A, B, C, okay? Now, the way which I'm going to label the sides is going to be in relation to these three angles. Does that make sense? Okay? So if that's capital A, okay, the angle which, so the side which A forms is this side over here. Do you see that? Because capital A, the angle A, is this angle here, which is the angle between these two lines. In other words, this side, the length of this side, is dictated by the side of this angle, the size of this angle. Exactly. So we label the sides with a lowercase a, okay? So capital letters for the angles, lowercase letters for the sides, okay? What side is this one going to be? Yep. And what side is this one going to be? B. Cool. Okay. So here is the idea, okay? I want to try and apply trigonometry to this triangle. Now, I showed you when we were talking through triangles that effectively, if I just chop a triangle in half by dropping a perpendicular line to an opposite side, I now have two right-angle triangles. In fact, I'm going to draw them out. So on the left, I've got this triangle. So this is going to be A, this is going to be C, okay, and this is going to be right-angled. And then on the right side, I've got this triangle here. This is going to be C, this is going to be A, yeah, good, and this is going to be right-angle here. Now, do you notice that the side which I've formed, so the length which I've used to cut this triangles in half, is the same in both triangles? Yeah? So that length there is literally that length there and that length there. So I'm just calling it H. H for height, I guess. Make sense so far? Okay, good. Now let's have a think. Let's have a think. So I have this angle and I have this angle in this triangle. What could I use? What trig ratio could I use in this left triangle? So have a think. This is the angle which I have. What is this side? It's going to be the opposite, right? So in other words, I have the opposite side. What's this side going to be in relation to this angle? Yeah, the C is going to be the hypotenuse. Does that make sense? Yeah? And likewise, you're happy this side here is still the opposite in this right triangle, and this is still the hypotenuse. So which trig ratio could I use to link these sides together with this angle? Sine. Good. So would you be happy that in the left triangle, I've got sine of, well, which angle am I looking at?
A.
Looking at A. So sine of A. What's that going to be equal to?
H over C.
Good. H over C. Yeah? And what about the right triangle? Still going to use sine. So which angle am I looking at?
C.
Good. I'm using sine C. Okay, so how could I link the two sides together?
A over A.
Opposite over hypotenuse. H over A. Yeah? Okay, good. Well, look, I guess if I multiply 3 by C on the left side, this left equation, would you be happy I get C sine A? Yeah, equals H. Happy with that? I've just multiplied 3 by C.
Yes.
Right triangle, if I multiply 3 by A, would you be happy I get A sine C? Equals H. Okay? Now just bear in mind, H was the same thing. H is literally the same length in both triangles. Make sense?
Yeah.
Yeah? So in other words, because this is equal to H and this is equal to H, would you be happy that C sine A would be equal to A sine C? Yeah? Good. Now, look, it looks a bit messy because I've got C's and A's on this side and A's and C's on this side. I'm going to rearrange it so I get the A's and the C's on both sides. Are you happy there's two ways that I can rearrange this? Okay? So one way is I could divide both sides by sine A and then divide both sides by sine C. Okay, so literally divide through by the sine of both sides. Okay, so if I divide both sides by the sine of A, would you be happy I get C is equal to A sine C over sine of A. Happy with that? And then I could divide both sides by sine of C to get C over sine of C is equal to A over the sine of A. Happy with that?
You just said sine A over A equals sine C over C.
Say that again.
Sine A over A equals sine C over
That's another way you could have arranged it. So you could have said, well, actually, I'm going to divide through by the sides instead. So I could have said, OK, divide through by both sides by C to get sine of A is equal to A sine C over C, and then divide through both sides by A. Yeah, so I get sine of A over A is equal to sine of C over C. So you're happy there's two equivalent ways that I could rearrange this equation. Okay, so I can have either, well, let me rewrite it out over here. Okay, A over sine A. Okay, now again, I could do an equivalent thing just by drawing a different sort of perpendicular in to prove that this thing would also have to be the same as B over sine B. And of course, it's has got to be equal to C over sine C. But depending on how I choose to rearrange it, the reverse would also be true. So I could equally say that sine A over A has got to be equal to sine B over B has got to be equal to sine C over C. You happy with that? You happy with how I found that? Okay. Now, because this has got sines in, okay, this will now apply to any triangle, regardless of whether it's right-angled or not. So let me get rid of that slightly, so you can see a little bit better what's going on. Okay. This thing will now apply to any triangle, Okay. As long as you say that whatever the angle is, whatever letter you give the angle, the lowercase letter is got to be the side which is opposite it, then this will always hold true. And because it has sines in, we call it the sine rule. Okay, we call this the sine rule. Okay, so let me give you an example of using this. Okay, let me give you an example. So suppose I have a triangle that looks like this. Let's suppose that I knew that this angle was 30 degrees. Okay, let's suppose that I knew that this angle was going to be, let's say, 40 degrees. And let's say that I knew that that side there was going to be 5, okay? And I wanted to find this side over here, okay? I could use the sine rule to find that, okay? So let's have a look. I always let A be the thing which I want to find. I let A be the thing which I want to find. So I want to find this, so I'm going to call this A. If this is side A, what's this angle going to be?
A.
Yeah, angle A, right? And let's just say that's B, in which case that's got to be capital B, but you could have also gone C and C, okay? Doesn't matter what you call it. So if I just use one of these two ratios, so either the top one or the bottom one, I should be able to work out what X is. Now, actually, you notice I have two, okay? The reason why I've given you two is because one is easier to use than the other in certain situations, okay? So you notice, with this first formula, what comes on the top? The sides or the angles?
The sides.
Yeah, good. So if you want to find a side, I would advise using the top one because the sides are on the top. It's just easier to rearrange. It doesn't actually matter. Okay. Whereas for the bottom one, because the angles are on the top, you would use this one if you wanted to find an angle. Okay, use that one if you want to find an angle. So what do we want to find? A side, right? We want to find X, which is a side. Okay, so in which case I'd advise using this one. Well, actually, because I've only got A's and B's, I can ignore the C over sine C. In which case I know that A over sine A has got to be equal to B over sine B. Does that make sense? Yeah? Then I just fit in what I have. So A, I've called X, right? So I have X. What's capital A? What's the angle?
Sine
30. So I've got sine 30 on the denominator. Okay. Now what's B? Lowercase b, side B? 5, good. And then what is sine of B? So what's capital B? Good, so it's going to be sine 40 on the denominator. Okay. Now I just want to find X. So what am I going to have to multiply through by?
We multiply 5 by sine 30 over sine 40.
Absolutely. So I just multiply through by this denominator here to get rid of it. So it's going to be 5 over sine 40. And I'm going to multiply all of that by sine 30. Can somebody stick that in your calculator and give it to me, please?
3.89.
3.89. There you go. Now, just be careful. What do I want to find here? Side or an angle? an angle. So I'm going to opt for the second formula. It's just going to be slightly quicker for me. Okay? It doesn't matter whether you use the top one or the bottom one, but I'd advise using the bottom one because it's slightly easier to rearrange. All right, let's have a look. So we've got sine of x over what? Over 5. Good. That's got to be equal to, well, it's got to be sine of 50 over 7. Good, exactly. So I want to find, well, x eventually. Let's get sine of x on its own first of all. How could I find sine of x?
Sine 50 times 5 over 7.
Yeah, just multiply through by 5. So I get sine of 50 over 7 times 5. If I want to find x, how do I find x from something like this?
Reverse sine.
Yeah, inverse sine, which remember on your calculator is shift sine. So sine inverse of all of this thing. Of course, if you were clever, you could just type that thing into your calculator. Then that will get stored as an answer. Then go shift sine of ANS, which is then the previous answer. Okay. So what do we get if we do that?
33.17.
33.17 degrees. Perfect. And that's your final answer. All good? Perfect. Fine. Let's take a 10-minute break and then we'll come back.